Everyone, welcome to Dr. Frank's Finance World. I am Dr. Frank, the bank, where I'm here trying to teach you something about finance so you can make some money on it going forward. So we're talking about bonds today, and this lesson is really about practicing problems. So I'm going to do the setup for you and that type of stuff. If you want to check out new stuff as it comes down, please hit subscribe or notifications and look in the notes for links and websites which we tend to update through time. So in this first case, you assume that you wish to purchase a 20-year bond that has a maturity value of $1,000. So this is a no video picture of me doing the video because I lean forward and do this on the computer a lot when I set it up. But anyway, because it's semi-annual, you'll see in the next line, it is a 20-year bond, and there are two semi-annual payments. So there's 40 periods we're going to be dealing with. The I that is required out there is a 10% yield by the market, but it too is semi-annual, and so that is 5%. The present value is what we're trying to find. It has a payment of, and it says up there, it is $40. It's $40. And it is the other part that is semi-annual. It says semi-annual payments of $40 right there. And then the future value of the bond is $1,000. So when we put that in our calculator, and I have that little sucker pulled up over here, I've already cleared out. I'm going to make sure I clear it out again, clear the time value money function. So we hit 40 for the N, and we hit 5 because it's semi-annual for the I, and we hit a payment of $40 that told us that in the problem, and $1,000 future value. We find that the bond should be selling for $828. And this makes sense because the market wants 5% and your bond is only paying 4%. So your bond will definitely sell at a discount. So, all right. Next problem we have. Ford Motor Company sold an issue of bonds with a 12-year maturity and $1,000 par value. So I'm going to start the problem there. The N is equal to 12 years. And the future value down here is going to be $1,000. And a 12% coupon rate. So we know from the payment part, we're going to take the coupon rate of 0.12. We're going to multiply it by the $1,000 face value. We know this thing is going to be paying $120 a year. 2 years after the bonds are issued, the going rate of interest on bonds such as these has risen to 14%. So we know now this is 14%, and we want to know at what price the bonds will sell for now. Well, this is the original time period of 12 years, but we have moved 2 years forward. Remember, the bond is marching from 12 years towards zero when it will actually mature, and we're 2 years later, so there's only 10 years left of remaining life on that bond. So in this case, the N is going to be 10, and that's how we will solve the problem to say what price it is selling for now. So pulling up the calculator again. Oh, sorry, we got into that one. Hit the wrong button. Put up the calculator again. We will clear the calculator out. And we have that the time period now has gone from 10 to 12 years. So we have 10 years, or from 12 to 10 years, 10 is the new N, if you will. 14% is what the market wants, which is quite a bit above the 12% ours is paying, so it will be a discount bond. We know 120 is the payment we will get, and $1,000 is the future value. When we compute that, we get a present price of $895.67.77. So this is a discount bond, and as it gets closer, selling at a discount, as it gets closer to the time it actually matures, you will see that the bond will sell closer and closer to the $1,000 face value. All right, so next problem. What is the value of an Orion bond that has a 10% annual coupon, pays interest semi-annual, and has 10 years to maturity if the required rate of return is 12%. So once again, we're going to have a discount bond here. And it's going to be, we're going to have to deal with the fact, PV, payment and future value. We have to deal with the fact that it is a semi-annual bond out there. So we know the N, the I, and the payment are going to be in semi-annual terms. So it's a 10% annual coupon payment. So the 10% times $1,000 means it's going to pay $100 a year, but it's semi-annual, so it's going to pay $50. semi-annually out there. And we know that it's $1,000 face value, and we know that it pays 10 years until maturity, but it's semi-annual, so there's 20 of those payments out there. And the market is wanting 12% semi-annually, which is 6% once a year. So when we run that through the calculator out here, we will clear it. Once again, I'm just going to clear this clear screen. Clear time value money right over here. We will have 20 periods until it matures. It will be at 6%, half of the 12. We'll be paying $50 twice a year, and it has a $1,000 face value. So we put all that in the calculator and calculate the current price. We have $885.30, which is what we expected because it's not paying what the market would like to get. Okay, so another bond problem. The required rate of return on bond is issued by Who Limited is 11%. Who has a bond issue outstanding that pays interest semi-annually, is selling for $8.45 and matures in 8 years. What is the annual coupon rate? So you have the N, the I, the PV, the payment, and the future value. We know that the future value for corporate bonds is $1,000. Required rate of return is 11%. It is issued, matures in 8 years, but is paying semi-annual, so we know these three will be different again. This will be times 2 because it's more semi-annual periods. There's 16 semi-annual periods. This will be divided by 2 because they'll pay, expect half as much a year. They'll expect 5.5%. And we know that the present value is selling for $845. Keep in mind, if you don't put a negative in front of here, you will get an error 5 on your calculator. So when you put that in, we'll actually be able to calculate the payment. It's going to clear the screen here. I'm clearing the time value money function over here. Cleared it a couple of times. 16 semi-annual periods is the N. 5.5, half of the 11%, is the I. We know that it is trading for $845. And this is where you hit the plus minus key down here. That's important to put the minus in there. Put that in as the current price. And we have the $1,000 is how much we'll get in the future. We put that in the future value. When we compute the payment, we actually come up with a payment of $40.18. I got to pull it up again. Sorry, so the screen goes away. 18 cents, $40.18. But guess what? We get that twice a year. So we're actually going to get $80.36 a year. And then the question becomes, what times $1,000 gives us $80.36. We divide both sides by 1,000, and what we find is the coupon rate, looking at coupon rate on this will be 0.08036 for your 8.36%, 8.036% is what would get you that bond payment. So the thing to learn from this problem is when you have to convert something back to semi-annual, you have to double it to make it annual again if you're going to do that type of payment on it. All right, next problem says, what is the yield to maturity of a zero coupon bond selling for $493.63 with 9 years to maturity? Well, I do them all the same. You know that by now. Payment, future value. It's going to mature at $1,000. We know that it has 9 years to maturity. We also know that the payment is 0. It's a zero coupon bond. And of course, we're going to do semi-annual. What I put in it? 9.0 years. 9 years is what it is. Semi-annual compounding. It is selling for $493.63. So there's 2 of these. We're going to be calculating the I. That's what we're looking for here. Get a little messy, sorry. And the payment doesn't matter because we're not getting any payment. But anyway, so there's going to be 18 semi-annual periods out there. And we're going to put this in the calculator to figure out what it's actually going to pay. So if I clear it out here and I put 18 for the semi-annual periods, and I have 493.63, and that is a negative because that's money out of pocket in order to get this future payment of $1,000, and that's the present value. We know the payment already is zero. When you clear it, it puts zero in there. And I put $1,000 for the future value, and we can calculate what the yield required on that is, compute the I, and we come up with 4%. But guess what? That's semi-annual, so we have to multiply it by 2 to turn that back into annual. It's an 8%. What's the yield and maturity of a zero coupon bond? 8% annual yield to maturity on that. Don't forget to convert them back and forth and to keep your negatives here in front of the present values when you're putting in the price like that. Getting close to the end here, you're evaluating a 9% coupon rate or coupon bond. Face value $1,000. The bond matures in 6 years. Yield to maturity is 6.8%. The coupon is paid annually. What should be the current price of the bond? Pretty straightforward bond problem here again. I, PV, payment, and future value. We know it matures at $1,000. We know that it is a 9% coupon, so 0.09 times $1,000 is $90. We know that the market wants 6.8%, and that you have a period of 6 years. And it's annual compounding, so we don't have to change anything on that. And we put that in the calculator. We'll see what we get. So I'm just going to clear the screen there. Clearing the time value money function. I'll do that. No, clear. I'll clear that a couple of times. We have the N is equal to 6. We have 6.8 for the yield for the market requirement out there is the I. We have $90 as the payment. And we have $1,000 future value. Now, before I hit the solve button here, the compute the present value, just remember, because the market only wants $68 a year, and your bond is paying $90 a year, your bond is going to be trading at a premium. So we know for a fact that this present value is going to be more than $1,000. We come up with it $1,105.51. So indeed, the bond is trading at a premium out there. All right, let's get to the last one here. Consider a $1,000 par value bond with a 7% annual coupon. The bond pays interest annually. There are 9 years remaining. What is the current yield on the bond, assuming that the required return is 10%? So this is an interesting problem, because to solve current yield, what you have to get is the payment that it's getting divided by the current price. Well, we know what the payment is, actually. We can calculate that. 7% annual coupon payment. So we know this is going to be $70 on top. But how can we find the current price? We don't have that. It becomes another bond problem where you have N is equal to 9 years. The I is equal to, so let's put future value down. Here's $1,000. I'll just go through it as it gives me information. 7% annual coupon, so you know the payment is equal to $70 to 0.07 times 1,000. Bond pays interest semi-annually, or pays interest annually. 9 years remaining. And what's the current yield bond with the required rate of return is 10%. So required return 10% and paying 7% or 70, you know this is going to be a discount bond. But when we put this in the calculator, we'll go ahead and clear it out. And we show that 9 is the N, that 10% is the market required yield out there, yield to maturity. That $70 is the current payment that you're getting, and $1,000 is the future value. When you can compute the present value, we get $827. So this $827.23, that's what that rounds out to, is what we have down here, the $827.23. And when we take the $70 and divide it by that, see, we can actually store this as 1. Then we can have the $70 that we're getting divided by the number we just found gives us a yield of 0.0846. So the current yield on that is 8.46%. It's a two-part problem. You can solve it, and you have sufficient information to solve it, but you have to solve for the current price in order to get the current yield. And that's just the final notes. I wanted to throw a current yield problem in there. Current yield is the payment divided by the current price. And then the yield to call happens when firms decide to call their bonds back. And what happens there is the future value changes because they usually pay you a call premium when they're paying you or bringing your bond back in. But the end shortens not to maturity date, but to when they can actually call it. So that's the two small differences you need to make when you're doing yield to call. Don't forget to send emails with comments and suggestions. Thanks for giving us your time today, and have a great day. Bye-bye.